Good evening everyone. Today we'll be starting with the module 4, that is mix design problem. So in this we will be designing the concrete mix, that is of the quantity what is required for the design, that is cement quantity, sand quantity, aggregate quantity and water quantity. So we'll go with the problems. Here there are two types of problems. So one is using superplasticizer and one is without using superplasticizer. First we will be going for the use of superplasticizer in the concrete mix. So the problem goes like this: design a concrete mix for M30 concrete with following data: type of cement OPC 43 grade, nominal size of aggregate 10 mm, workability 150 mm, slump exposure condition moderate, plain concrete, method of concrete placing, pumping, chemical admixture, superplasticizer, test results, specific gravity of uh, cement 3, specific gravity of coarse aggregate 2.82, specific gravity of fine aggregate 2.75, specific gravity of super plasticizer 2.10. Sand belongs to zone 3. So sand, there are four types of zone: zone 1, zone 2, zone 3, zone 4. In this problem it belongs to third zone. So we'll go to the solution. So in this we'll be using the codebook IS 10262-2009. Using that codebook we have to design the concrete quantity whatever is required. So in the first point in that we are going to determine is target strength for mix proportioning. So to calculate the target strength for mix proportioning, that is nothing but how much target you all are going to keep, that is M30 grade concrete is there. Your strength, whatever the compression strength you are going to get, that target strength we have to calculate. So to calculate that we are going to use the formula, that is FCK dash is equals to FCK plus 1.65. Yes, S stands for standard deviation. This we will be getting it from table 1. So table 1 according to your code book is assumed standard deviation. Depending upon the grade of concrete, you have assumed standard deviation depending upon the grade of concrete. For M10 and M15 it is 3.5, 20 and 25 it is 4, 30 to 55 it is 5. So our problem which is going to deal now, it is having M30 grade concrete, so our standard deviation will be 5. So you have the formula also in the code book, you can see here, that is FCK is equals to FCK plus 1.65. Yes, FCK dash is equals to target mean compression strength for 28 days. FCK is characteristic strength for 28 days. So target mean strength also you need to calculate. For that you require characteristic strength. So using that formula, substituting the values, we have the characteristic strength 30 plus 1.65 into 5. Once you multiply, you're going to get the answer, that is FCK dash target strength for mixed design. You are going to get it as 38.25 Newton per mm square. So next, second point is selection of water cement ratio. How much water should be added, that you are going to calculate here. So to calculate that, what you are going to do, water by cement ratio you need to calculate first. So using the code book again, that is IS 456 RCC design code book, when you use, you will be having the table number 5. So this is the table number 5. You will be having the minimum cement content, maximum water level, maximum water cement ratio, minimum grade of concrete. So this table deals like this. So you have plain concrete, minimum, maximum, minimum grade of concrete. Even RCC also you have minimum cement content, maximum water cement ratio and minimum grade of concrete. So our problem is having plain concrete. So for plain concrete and it is plain concrete plain concrete and moderate region it is. So it is having the maximum free water cement ratio you have is 0.6. So depending upon the condition or exposure condition, you need to select the maximum water cement ratio using this table number 5. Even minimum cement content also you will get from this, which will be doing it in the third point. So once you select that, from the table 5 of IS 456 maximum water content ratio, we have got it as 0.6. So minimum cement content, that is what I said here in the table, you have minimum cement content also. So minimum cement content is for moderate condition is 240. So that 240 you need to consider here, but this is for 10 mm size of aggregate. But as it is having more than 10 mm, that is 40 mm size aggregate, so for that we need to calculate, we need to add extra amount. So you have in this table here minimum cement content from table number 6. So table number 6 you have here adjustment of minimum cement content for the aggregate rather than 20 mm nominal size. So for 20 mm nominal size, those maximum cement content is given. Other than that, if you have, because in our problem we have 10 mm down aggregate, so for 10 mm down aggregate you need to add 40. If you have 40 mm down aggregate, you need to minus 30 in the minimum cement content. So minimum cement content according to the moderate condition you have 240, and adjustment needed to be added because it is other than 20 mm down aggregate, so we need to add 40 extra there. So 240 plus 40, you will be getting the minimum cement content to be 280 kgs per meter cube. So this is the second point. Going to the third point, selection of water cement, selection of water content. Selection of water content, again you will be using table number 2 from 10. Table number 2 you will be using. So for using table number 2, you will be getting maximum water content per meter cubic. So for per meter cubic, so size of aggregate is as is 10 mm, so maximum water content you are going to take is 208. But this will be only for 25 to 50 mm slump. Means if your slump value is between 25 to 50, you can directly take the maximum water content given in the IS 10262 directly these values. But if it is other than 20 to 25 to 50 mm slump, you have to add some percentage. So now we have here is 150 mm slump. So for 150 mm slump means for 50 it is already 208. For 150 means remaining 100 we need to add 3%. So we have to split it as 25%, 25 mm, 25 mm, 25 mm, 25 mm. So for 100 mm slump, 25 mm you need to take. So 25 can be split into 400. So it will be 4 into 3%. For every 25 mm you need to increase 3%. So for every 25 mm 100 is remaining. So 25 into 4 it will be equal to 100. So you need to increase 12% here. 12% of whatever the maximum water content is that you need to increase it plus 208. So this is the third point. Next one is we need to take, as we are using superplasticizer here, so the water content can be reduced up to 20% and above. So but according to the code book, 29% of water content can be reduced and it can be achieved. It is according to the code book, that is 29% can be achieved. So hence arrived water content will be remaining out of 100%, 29 can be achieved means remaining will be 71%. So you need to multiply 71% to the water content whatever you have got, because we are using superplasticizer here. If there is no superplasticizer, then not necessary to multiply the value whatever is calculated here. Next, fourth one is calculation of cement content. Now already we have found out water cement ratio, that is water by cement ratio already we have found out. So cement content will be equal to water also we have already found out, that is this one. After using superplasticizer, whatever we have got the answer, that should be divided by water cement ratio, then we'll be getting cement content. This cement content should be compared with our table number 5, that is IS 456. Minimum cement content according to IS 456 is 240 and we have got 275. So it is okay, means we are getting whatever the minimum content is there, more than that we are getting. So our design is correct. So you can see here minimum cement content for moderate condition it is 240. For moderate condition it is 240 and we are getting more than 240. So our design is correct. So next one is fifth point, that is proportioning of volume of coarse aggregate and fine aggregate. As in our problem, if the sand belongs to third zone, cement water by cement ratio, whatever the table number 3 is there according to IS 10262 2009, this table is for water cement ratio of 0.5, means whatever the zones are there and aggregate is given, this was for water cement of 0.5. If it is other than 0.5, then you need to add some percentage or minus some percentage. So that we'll be seeing here. Sand is third zone, 10 mm aggregate. 10 mm aggregate means here it is as water cement volume of coarse aggregate will be 0.8, it will be 0.48. So 0.48 corrected proportion of volume of coarse aggregate for water cement ratio of 0.6. Now we are getting water cement ratio as 0.6, but this table is for 0.5. So you need to subtract 0.01 for every 0.05 water cement for every 0.5 volume of coarse aggregate. So 0.1 there is difference, so you need to minus 0.01 minus 0.01. 0.1 for every 0.05 you need to minus it. So we'll be getting the corrected volume, that is water by cement ratio is 0.46. Using this we need to calculate volume of coarse aggregate and volume of fine aggregate. So volume of coarse aggregate will be out of 100%, 0.9% we are going to take it as coarse aggregate. So 0.46 into 0.9, that is 90%, and 90%, only 10% you have to neglect it. So 0.9% you need to multiply, then fine aggregate out of 100, 1 minus whatever the answer you have got. So like this you will be getting volume of coarse aggregate and fine aggregate. Next one is mixed design calculation. So for 1 meter cube of concrete, how much volume of cement is required, how much volume of water is required, separately you need to calculate. Now for a volume of concrete, for 1 meter cube volume of concrete is there, so calculate the volume of cement. Already mass we have, specific gravity also we have, divided by 1000. So mass is cement, whatever the quantity of cement we have got, that should be divided by specific gravity into 1 divided by 1000. To convert kgs to meter cube, that 1 divided by 1000 you need to multiply. So we have got volume of cement, that is 0.091 meter cube. Next we need to go for volume of water. Already you have calculated water quantity, that is in liters, divided by specific gravity. Of specific gravity of water, if they have not given, you can take it as 0.98 or 1 directly, then into 1 divided by 1000. So similarly you need to convert it to meter cube, so we are going to multiply into 1 divided by 1000. So we are going to get whatever the required answer. Next one is, as superplasticizer is used here, you need to calculate even the volume of chemical admixtures. Chemical admixtures for every cement content, whatever cement content is there, into 2% you need to multiply. Whatever the cement content we have got, the same, that you need to multiply into 2.2% by volume of cementitious material. Means 2% you're going to reduce cement and you're going to add the chemical admixture there. So you will be getting the value here, that is 5.52 divided by specific gravity of cementitious material, that is chemical admixtures into 1 divided by 1000. So your answer will be 0.002 meter cube. Next, volume of all in aggregate. Now we have already calculated cement volume, water volume, volume of chemical admixtures. Now we need to calculate volume of coarse aggregate and fine aggregate. So already we have found out coarse aggregate and fine aggregate, volume of all in aggregate. So in that, what you need to do, in concrete you need to minus volume of cement, volume of water, and volume of cementitious material, that is chemical admixtures, you need to minus. In total concrete you need to minus volume of cement, volume of water, and volume of chemical admixture. So you will be getting volume of all in aggregate, that is 0.741 meter cube. Next one is mass of coarse aggregate. Already we have found out volume, so here you need to calculate the mass, because still we have not got the mass, but remaining all we had got in terms of mass. So coarse aggregate and fine aggregate we had not got in mass, so you need to calculate that by all in aggregate. Whatever the volume is there, that you have to multiply into volume of coarse aggregate into specific gravity into 1000. So you will be getting the mass of coarse aggregate. Similarly, you need to calculate mass of fine aggregate also, that is volume of all in aggregate into volume of fine aggregate into specific gravity into 1000. 1000 is nothing but this E is nothing but volume in all aggregate, that is in meter cube. You need to convert it into kgs, so multiply into 1000. So already I have got cement, water, fine aggregate, coarse aggregate, at chemical admixtures, and water cement ratio. That you need to write it separately by telling that mix proportion for trial number 1. This is just a trial you are going to do. So what you are going to get, cement, what is the quantity you have got, that is 275.72 kgs per meter cube. Water, what is the quantity you have got, 165.43 kgs per meter cube. Fine aggregate, 1181.895 kgs per meter cube. Coarse aggregate, 875.65 kgs per meter cube. Chemical admixtures, 5.52 kgs per meter cube. Water cement ratio 0.6 we have got. So like this you need to calculate the mix design problem. One by one you need to tell what is the quantity of cement, water, fine aggregate, coarse aggregate, chemical admixtures if it is given, and water cement ratio. This completes the problem. Next problem we will be doing it in the next part of the video. Thank you.